Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 11 students and the topic of discussion is Binomial Theorem. This is an introductory video on this topic. So what does binomial means? Bi means two. So binomial means sum of two variables like this x plus y. And what is binomial expansion? X plus y power n. We want to find x plus y power n through binomial theorem. Let us start with n equal to small values like n equal to 0, we know x plus y power 0 is 1. Similarly, x plus y power 1 is x plus y. X plus y power square also we know. X plus y power cube also we know. X plus y power 4 can be found by x plus y square into x plus y the whole square. So we will get this expression. So what is the difficulty here? Difficulty is, suppose I ask you to find x plus y power 10 or x plus y power 20. Then what will be the expression? It becomes tedious using the standard procedure. So binomial theorem or binomial expansion helps in finding x plus y power n when n is large. Let us take this expression x plus y power 4. This is the answer we got on expanding. What we observe from this, total number of terms in the expansion is one more than the index. So what is the index? Index is 4. Let us count the number of terms 1, 2, 3, 4, 5. So the number of terms is one more than the index. Powers of the first quantity go on decreasing by 1, whereas the power of the second quantity y increase by 1 in the successive terms. Let us see. First term is x, so its power will start with x power 4 and it keeps on decreasing x power 3, x power 2, x power 1, and this can be thought as x power 0, which is 1. We can add it here. Similarly, let us check y. Y is y power 0 here, which is 1, y 1, y power 1, y power 2, y power 3, y power 4. In each term of the expansion, the sum of the indices of x and y is the same and is equal to index of x plus y. What is the index of x plus y is 4. Let us see the sum of indices of x and y. Here only x term is there, which is power 4. Here x power 3 and y power 1. So 3 plus 1, 4. Similarly here 2 plus 2, 4. Here x power 1 and y power 3. 3 plus 1, 4. Here again 4. So each term of the expansion, the sum of the indices of x and y is same and is equal to the index of this term. Now let us take this expression again, x plus y power 4, and we get the expansion as this. We have seen earlier that getting the terms x4, x cube y, x square plus y square, xy cube, y4 follows certain order, which is easy to get. But what about this coefficient? Here coefficient is 1, 4, 6, 4, 1. Whether do we have any formula or some setup to get these coefficients? Let us see this using the Pascal triangle. What is Pascal triangle? In this each row we write starting with 1 and the first and the last number as 1. So second row will be 1, 1. Third row, first number will be 1, last number also 1. Fourth row, first number and last number 1, and so on. We construct a triangle shape like this. But what about the intermediate terms, in between terms? So 1 plus 1 will be 2, 1 plus 2 will be 3, 1 plus 2 will be 3, 1 plus 3 will be 4, 3 plus 3 will be 6, 3 plus 1 will be 4, 1 plus 4 will be 5, 4 plus 6, 10, 6 plus 4, 10, 4 plus 1, 5. So we can do like this. We can construct this triangle and this is called as the Pascal triangle. What does it do? Pascal triangle helps in getting the coefficients of the expansions. So this is x plus y power 4. There will be 5 terms in the expansion. So 5 terms, we select this row with 5 terms. So first coefficient will be 1, second coefficient will be 4, third coefficient will be 6, fourth coefficient will be 4, and fifth coefficient will be 1. So through Pascal triangle we can get the coefficients, and the other terms through proper observation we have seen earlier, like first term will be x power 4, then second it will keep on decreasing, x cube, x square, x and x power 0, y term will be keep on increasing. So we can get the expansion of the binomial terms x plus y power n. But still there is a problem. Pascal triangle can help for small numbers of n, like this. Suppose I say find x power 30, but we cannot do this, construct the triangle up to 30 terms. That becomes more tedious. So you may be wondering whether is there a general solution, or is there a formula, simple formula through which we can get all the terms? Yes, we can use a formula to get the terms of the binomial expansion. Let us see that. But before we do that, let us take one simple example to expand x plus y expression. So let us expand 2x plus 3y power 5 using Pascal triangle. So we construct the Pascal triangle like this. We have told, like for example, first and last term will be 1, and the intermediate terms will be the sum of the previous row, 1 plus 5, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, 6. So in 2x plus 3y power 5, there will be 6 terms. We know that 5 plus 1. So this row contains 6 terms. So the coefficient will be 1, 5, 10, 10, 5, 1. That's what we have written, 1, 5, 10, 10, 5, 1. And first power will be 2x power 5. Then it will keep on decreasing, 2x power 4, 2x power 3, 2x power 2, 2x, and here will be 2x 0, which is 1. Similarly, y will gradually increase by 1. So first will be 3y 0, which is 1, then 3y, 3y square, 3y cube, 3y power 4, and 3y power 5. So we can see that Pascal triangle helps in getting the coefficients of the binomial expansion. Now we will go to the generalized formula when n is large. Now let us find the equivalence of the Pascal triangle. We know this is the Pascal triangle we have seen earlier. So can we write a generalized formula for the coefficient? Yes. This is the thing. 1 is equal to CC0, 0. Similarly, 1, 1 is 1C0 and 1C1. And 1, 2, 1 will be 2C0, 2C1, 2C2. Where NCR we know this is a combination formula, n factorial by r factorial into n minus r factorial. In case you don't understand what is this, I request you to please go through my previous videos on permutations and combination. So what I am trying to say is the Pascal triangle can be equivalently written in terms of the combination formula. So for example, if you want to get the fifth row, this is first, second, third, fourth, fifth row. So we will write 4C0, 4C1, 4C2, 4C3 and 4C4. So this can be written in a general formula. X plus y power n is equal to sigma r equal to 0 to n NCR xn minus r y power r. What is this sigma? Sigma means summation, like plus terms. These all plus terms, when we include, it comes under the heading of sigma. That is sum of all these terms. This is the general formula for a binomial expansion. Let us take one example. Here we need to find the 8th term of the expansion x plus y power 13. What will be the first term? First term will start with x power 13, and there will be no y term, so we can write it as y power 0. So x power 13, y power 0. So first term is y power 0. So what will be the 8th term? 8th term will be y power 7. So that's what 8th term, y part will be y power 7. Since sum of the x and y powers will be equal to 13, x has to be x power 6. So this we know. What will be the coefficient is 13C7. We know that there are 13 is the power here. So n will be 13 and it will be 1 less. Since it is starting with 0, this will be 8 term will be r will be 7. That is 1 less than the term required. So our expression for the 8 term will be 13c7 x6 y7. Let us expand this 13c7, that is equal to 13 factorial by 6 factorial into 7 factorial. 13 factorial can be expanded till 7 factorial. 13 into 12 into 11 into 10 into 9 into 8 into 7 factorial. Why we stop 7 factorial? Because there is a 7 factorial in the denominator. So we can cancel that. Now 6 factorial we expand, 6 into 5 into 4 into 3 into 2 into 1, and we get the coefficient as 1716. So the 8th term of the expansion x plus y power 13 is 1716 x power 6 y power 7. Friends, with this we conclude this video. Please like and subscribe my channel so that in future videos can be released to you instantaneously. Thank you very much, friends.